Hey everybody, welcome back. We're still here at Techorama NL 2018. This is dotnetFlix Live, and we got a very special guest, Leonard Lobel. Welcome to our booth, and
thank you, Edwin.
Maybe you can introduce yourself to our viewers and tell us what you do.
Thanks, Senator and Edwin, for inviting me. My name is Leonard Lobel, and I'm from New York City. I run my own company there called Sleek Technologies, but I really just like to build applications. I'm a senior architect, and I do software development and also database development. And I'm Microsoft MVP and data platform, and I'm just thrilled to be here at Techorama 2018.
Cool. And you did 2 sessions here, right, on Techorama?
2 sessions this
yesterday
year,
was around CosmosDB. Can you tell us a bit about that?
Sure. So yesterday I had a talk around Azure CosmosDB. Developers today absolutely need to get up to speed and on board with NoSQL. It's no longer an option to hope it's going to go away, think it's going to go away. It's not the answer to all your problems, and it's definitely not something you have to embrace unless you really need this scale.
Yeah.
But more and more we need that scale. And if you're building a modern web and mobile applications today, it's most likely that they're global applications in nature. CosmosDB is built to be a globally distributed database. It's as simple as clicking the mouse on a map in the portal, literally where you want your data to be distributed.
And it's all about getting the data as close to the clients as possible, right?
As close to
wherever you are in the world.
Wherever they are, you stand up an application server, and you just set up a geo-replication and have CosmosDB with a click of a mouse automatically replicate your data, whether it's Southeast Asia, no matter what.
Pretty cool.
Yeah, very cool. But it's not just about bringing it closer, it's also wherever it is, allowing it to scale. And not just in terms of storage, but throughput. So there's horizontal partitioning, where if you pick the right partition key, you will never have to manage the growth of your data. When you're in the SQL Server world, you know how painful that can be.
Yeah, that's bliss. If you don't need to worry about that.
You don't have to worry about managing the growth. You'll get predictable performance. We all know how difficult that is to achieve. But you can provision throughput for your needs, and you will be guaranteed by service level agreement to get that throughput. And you'll guaranteed to have that amount of performance level available to your application every second of every minute. So there's scale, not just in terms of storage, but also throughput. And then, of course, there's this whole notion of schema-free, which is a bit of a misnomer, because there is schema, it's just there's no schema management, there's no burden of schema management. But of course there is still schema in the forms of keys and values, but being a multi-model database with multiple APIs, you can choose to treat your data however you like. You can treat it as JSON documents, you can treat it as a key value, as a simple table key value store. There's a Gremlin API that lets you implement a graph data model, which is increasingly popular nowadays, graph database with a focus on relationships. And just recently, I think within the last several weeks, the Cassandra API was just launched to general availability. It was in preview for a while.
Pretty cool.
By the way, I glossed over another important note about global distribution, that while you can globally distribute anywhere in the world, those are multiple relocations. There's only a single write location, but now they are previewing the multi-master feature, which allows multiple write locations.
That's what Scott also showed in the keynote, right? In the keynote.
That's still in preview right now?
Sorry? That's in preview right now. You might even be by reservation only. I'm not sure, but you can sign up for it and check it out. So you have your choice of data model, but no matter what you pick, document, graph, table,
SQL,
columnar. Well, document is SQL. It's a little strange.
It's from misnomer, I think.
It is. Well, CosmosDB came from DocumentDB.
Yes.
And they changed the name to CosmosDB in 2 parts. Well, calling it CosmosDB definitely emphasizes the globally distributed nature of this database. And not calling it DocumentDB anymore simply because it's no longer limited to documents. So when CosmosDB launched, at that point in time, DocumentDB became one of several APIs, the DocumentDB API alongside the MongoDB API, Cassandra API, Gremlin API, Table API. But then very shortly after that, somebody decided DocumentDB is just a dirty word, and it is simply called the SQL API. Just to add to the confusion, guys, it's the SQL API of Microsoft's premier NoSQL database.
And what I really like as a developer also is the consistency models that you have. That you can actually almost have a slider in which you can say, I need to be very consistent, or I need to be...
It's not either strong or eventual.
No, exactly.
So it's a sliding scale, but what's interesting is that until you start to geo-replicate, it's almost impossible to ever get a dirty read.
Yeah.
Because they're going to stand up 4 replicas at a minimum, and then more depending on how much throughput you provision. But those replicas update typically within 1 millisecond of one another, and it's almost impossible to get a dirty read. Instead, the consistency model becomes a much more pressing concern once you start to globally distribute, right? Because now it takes hundreds of milliseconds for data to traverse continents, and
makes
suddenly
sense.
consistency, am I getting the latest version of the data? That becomes a much more pressing concern.
And I guess when you're moving to multi-master, multi-write regions, there's this same kind of slider, is there, to how to deal with conflicts?
There is a conflict resolution strategy in place to cope with that as well. Yeah, but again, that's in preview.
So another thing that I find very interesting about this multi-model is that if I've got an existing workload using MongoDB or Cassandra, I can now simply move that workload to the cloud, get that global scalability, and not needing to rewrite my application.
Indeed, when developers ask, why would I choose one API over another? I mean, the existence of the MongoDB API and the Cassandra API is exactly the scenario you mentioned. In a way, it's a way for Microsoft to cast a wider net around more and more customers come to our side. Because this is wire level support we're talking about, so it's not just the data model, it's also all the APIs and the whole protocol stack is fully emulated. So if you're a MongoDB person and you have an existing MongoDB application and you want to continue leveraging your skills and port that application and continue extending it, but enjoy horizontal partitioning, limitless scale, limitless throughput, global distribution with CosmosDB as a backend, that's very compelling.
Yeah, and who doesn't like that, right? It's pretty cool. Yeah, nice.
So, but I guess relational databases are also.
I'm making it sound like they're dead. I'm making it sound like those are dead, right?
They're not dead yet, right?
There are those who would have you believe that their demise is imminent. But that's in fact, of course, depends who you're talking to. In fact, of course, not the case. There are many, many things that you can still only do with relational databases that you can't begin to dream of doing with NoSQL databases. With NoSQL databases, it's all about scale. If you need that limitless throughput, that limitless scale, that global distribution, the fricction-free schema management, all of those things. But if you only necessarily need schema-free, friction-free schema management, then you can embrace JSON in the relational database. So it's definitely not dead. And in terms of my session today, we were talking about good old relational, traditional SQL Server, and the very latest security features that have been added to our good old relational database product, which is still very, very. I mean, as good as they are, what they do, they might not scale to limitless scale like a NoSQL database, but they are quite mature and extremely powerful, and they have a lot of features baked into them. Three of which I discussed today in my talk on security features.
Yeah, so the first one was dynamic data masking. Can you tell me something about that?
Sure. Well, dynamic data masking is the least secure of the security features. It's not really intended to discourage or thwart malicious users that are really looking to do damage or harm, but rather you might have a group of developers and they're not out to do any damage, but still they should not be looking at social security numbers and credit card numbers. They should really be hidden. But you don't really have to worry about them deliberately trying to go in there and crack them. What they really need is they need some data that's a good representative sample of production data. It's really hard to get. I was in the healthcare industry.
It's a big problem,
3 years I spent in the healthcare industry begging for sample data, where there was always an issue of scrubbing the data, anonymizing the data, sanitizing the data.
Takes lots of times. It's very expensive to do
by
that.
the time I got set that data at that stage, the schema had already changed and it was useless. So the ability to just have a bunch of developers in a role that lacks the special unmasked permission. By lacking that permission, they won't be able to see any of the columns that you mask. But this is not encryption. It doesn't modify the data on disk. And you can certainly, it won't break anything. It's compatible. You'll be able to join unmasked columns. You'll be able to query on that. If I query where last name equals Smith and the last name column is masked, I will get back all the rows where last name equals Smith. So let's understand this is not encryption. This is just hiding the data.
Think of it masking, right? So
and it happens at the point in time, just at the latest point in time, as the results that is about to be projected.
That's a small
SQL
filter
Server
of
looks at the
yourself.
connection and say, do you have the unmasked permission? And if you don't, then it masks.
Okay, makes sense.
Cool. Then there was also this feature called row-level security.
RLS, row-level security. Yeah, this is securing at the row level, right? So we're talking about basically filtering or hiding rows from users that shouldn't be able to see those rows in terms of ownership from one user to the next, depending on the data in the row, depending on the user running the query, you may or may not want to allow the user to see the row.
Yeah.
But this is nothing new. It's not a new requirement. We've baked this into our application tier over the years, over and over again. Now it's at a level so deep in the database you can't circumvent it because it operates on, at its core, it operates on the principle of a join, an inner join, which will just filter data. You write a predicate function that examines each row and returns true or false, and that predicate function is essentially cross-applied in a join fashion. So if you're looking at a table of millions of rows, you do a select count, it shows only 10, because you can only see 10 of them. And it just looks like there's 10. That's your view of the table. And then you can also apply the same type of control over updates as well, for blocking, not just filtering, but also blocking. There are all sorts of scenarios. You can have a scenario where I can only see my data, I can only update my data. But it's really, there's a lot of granularity. Imagine a hospital where a nurse should be able to see all the data, but still only update particular data. You can mix and match these predicates in different ways and achieve the results.
Yeah, you fix it all at the source, right? So in your application, you can just rely on that you don't get data that the customer doesn't.
You don't have to worry about filtering.
That's pretty
it's
cool.
It's all on the connection. It works with either a dedicated. It works with one database connection per user. We have a database user per user, and it also works in n-tier scenarios where it's a shared database account, a single service account. If you combine RLS with a session context feature, you can establish from context who's who.
And you talked about the masking feature is not actually encryption.
Certainly
is there real encryption also in there?
When you need to actually encrypt, you'll want to check out the always encrypted feature. So that was a third of 3 features. Now encryption in SQL Server is not new. There's been key-based and certificate-based encryption for a while. And there's also transparent data encryption, which will encrypt the entire database and backups. And they serve us well, but they only protect data at rest, and that was fine before the days of the cloud. But today, one of the things holding back most people from moving their database to the cloud is there's encrypted data in the database, and they don't want to decrypt it, and they don't want to, nor do they want to hand over the encryption keys to their cloud provider. There's no separation of those who own the data from those who manage it. Microsoft in the case of Azure.
Which is really understandable, right? If you encrypt something, you don't hand out the keys and stuff, so
And that's exactly what this does, is it gives you a clear separation. It's encryption, but the keys are not stored in the database. It's a very elegant mechanism where the one key, the master key, is client-side, and it's used to encrypt all the other encryption keys that are in turn used to encrypt your data. But they are only client-side, so always encrypted actually means never decrypted in any location other than the client. It's actually, it's funny because if you've been doing this a long time, maybe as long as I have, you might remember back in the days of Foxborough and DBase, right? The database didn't have any encryption capabilities. If you wanted to encrypt a password or a credit card number, how did you do it? In the client.
In the client, send it encrypted.
Right, you store it in the database, pull it back, garbage in, garbage out. Classic Giga, right? In a sense, always encrypted today is a throwback to that old school way of doing things, where it's the client that does it, and the database says, I don't know, I can't interpret this data because it's encrypted. But with this magical modern twist that, back then you had to do all the work. You had to do the encryption. Today, it's a change on your connection string, and it just happens transparent.
And I guess that's still true for stuff like CosmosDB, because I don't think CosmosDB has encryption.
Well, with CosmosDB, everything's encrypted all the time.
All the time?
Everything's encrypted.
So it's not
on the wire and on the
default.
There's like nothing to talk about.
But these features that you talked about, this is all available right now in the latest version of SQL Server, right?
1000%.
No previews.
All 3 of them are available in SQL Server 2016 and higher. And I should also point out that the first 2 of those, dynamic data masking and row-level security, initially were released as enterprise-only features, but that they very quickly rolled that into standard, which is really, really great.
That's important.
And always encrypted, although it is enterprise-only, it really targets Azure SQL database. It's designed. it's designed to remove your fear about moving your database to the cloud. And if you embrace always encrypted, you can move your database to the cloud without moving your keys.
Yes, that's pretty cool. Okay, well, thank you so much for talking about these cool technologies. Yeah.
Thank you, Edwin. Thank you, Sander.
Thanks.
You guys have done a fantastic job, and just loving every minute of Techorama.
Yeah, you like the conference, right? So it's the first time in the Netherlands, so we're really proud of this, and we really like it.
Excellent.
So,
Most excellent.
Thank you for watching, and see you at the next one. Bye-bye.
Bye, everybody.
Bye.